My name is Andrew Joseph. This is Anup. We are from EigenLayer, the creators. We work at EigenLabs, the creators of EigenLayer. And we're going to talk about AVSs. What are AVSs? AVSs are actively validated services.
This lights.
Okay. I think it's fine. They can hear us. Like, can you raise your hands if you can hear us? Yeah, they can hear us. Yeah, thank you. Why we'll talk about why build an AVS, an overview of EigenLayer, and Anu will give you a demo of a Hello World project. This is this is available on GitHub, so you can like use it as a starter project. We are sponsoring bounties today. Uh, One is an AI bounty, so you can create like an AI agent on EigenLayer, and one is a novel use case of EigenLayer. So uh, we'll give you some ideas towards the end of this presentation on what to build and all that. So why build an AVS, right? So what is an actively validated service? Uh, so imagine Ethereum, right? Like we have so many services built on Ethereum, like bridges, for example, oracles, and we need all this to like run DeFi or lending markets, right? Like all of these applications we built on Ethereum requires all these services like oracles, bridges, whatnot, right? These are services that are external to Ethereum, and these require some sort of security, so we can use them and be confident that our funds are safe and secure, right? And how do you secure them, right? Like we secure it with like money, like capital backing these services. Honestly, that is called economic security, and EigenLayer is a service that allows you to easily bootstrap economic security without spinning up your own network and asking the stakers to like deposit funds or like paying out operators with inflation of your own project's tokens and things like that. So when you're launching a new Web3 project that requires bootstrapping any sort of like a network, like a bridge, for example, or an oracle, or a DA layer, intents, all of that can easily be solved by EigenLayer because EigenLayer allows you to easily bootstrap economic security. So an easy way to think about economic security is that imagine a bridge that wants to bridge like $1 million back and forth between two different blockchains, right? If the bridge is not secured by more than $1 million, it always makes sense to attack the bridge and get their money, right? So crypto economic security is the cost of attack should always be higher than the profits you gain from attacking the system, right? So that is what we are talking about when we say economic security. And what is a shared security, right? So if every network, like every oracle or every bridge, were to bootstrap their own economic security, you would split up the capital, and it will be very inefficient, right? Like we have like multiple layer ones today. Imagine they all shared like security, then it would be like a better system. But when you split up capital, it becomes capital inefficient, and the cost of attack goes down. So pooling capital together increases the cost of attack. So that is what we mean by shared security. So different services share a pool of capital, and that increases the cost of attack, and it is capital efficient. So let's talk about uh, how shared security works on EigenLayer. We have restakers, so users like you and me can deposit funds on EigenLayer, and we delegate that capital to operators. So operators are like service providers like Coinbase, Figment, like anyone who could run a validator could be an operator. It is all permissionless, right? So we have operators, and actively validated services are the products you will build on EigenLayer. So things like oracles, bridges, AI agents, all of them are AVSs. And we package this, and a consumer would be using your services like the agents, the bridges, the oracles to do what they want to do, right? And so how does this flow, right? So risk-takers delegate their capital to operators, and operators run AVSs. So that is how it works on EigenLayer. And now Anup will give you an overview of a very basic AVS. And yeah, I'll hand it over to him.
Hi everyone, I'm Anup. I'll go over a very basic AVS to help understand how the system interacts and how you would build the AVS that you want to build. And I'll give you links for more complex AVSs that are live today as well. So let's take a very simple hello world example, which is you, let's say the consumer, have a need to say hello on the contracts and secured by EigenLayer using an AVS as well. So what the flow here that you're seeing is you would send a request on chain to say that, hey, I want to say hello to the world. And a transaction is sent on chain and an event is emitted. The operators that was described earlier will look at these events and say, oh, I actually have work to do. So it will download this event from using your RPC and other things, and it will have predetermined code as part of the design of the AVS and say what needs to be done. In this specific case, it's very simple. It says, oh, I need to say hello world and sign it and send it over. So that is step 3 and 4 that you're seeing. After the event is received from step 2, the message hello world is seen, signed, and the data is sent on chain. And step 5, where you see the amount of stake and what is needed, is calculated. And these options are actually up to the AVS to define how you would want to calculate and hold all these things together. So let's go through a simple demo here, and I'll go through the code as well. Okay, so the screen up top that you're seeing is going to be the AVS code, and as you see, it starts an anvil chain. I will share the link for this code that works, and you guys can fork it and build very easily on top of it. The next 2 things what we'll do is deploy the EigenLayer contracts and deploy your AVS contract. So with this, what you're doing is you deploy all the things needed for EigenLayer to work, and you deploy your hook, your AVS hook. We call it a strategy manager, service manager, sorry. And we use that to talk through EigenLayer and have the mechanics work with it. So on the left side, both the EigenLayer contracts and AVS contracts have been deployed. So now we will start an operator. And as you see, the operator is written, you have option to write the operator code in any language you wish to use, as long as it conforms to the spec that we have, and then it serves your use case as well. So here I'm using the Rust operator to run a single operator for the AVS. And on the left side, I'm saying, run some hello username example. So in a few seconds, it's building. So here, as you see, it sent a task saying that Hungry Dog 500 is what I want the operator to respond. And that is the task that is sent on chain. And you can see through Anvil that you have tasks registered and you have the response from the operator as well that you see here on the bottom left screen. The operator received a new task, hello Hungry Dog, and it responded, and with the transaction hash. So we run this for couple of while, and this can be long running services, and it depends on you and how you want to define your AVS. So I'll go through the code on what this looks like. So as you probably remember, we have a create task, something that you, consumer, would actually need to create a task to interact with the system. And you have the respond task, which is how you would actually respond to the task you received. And this is the contract that you're seeing. And as you if you see in the respond to task, you have the reference checks on am I supposed to respond to this task? Does it match my requirements? And is this actually something that I care about? And after all those checks, you see the message hash, which is hello and the task name that was sent. It is signed and it is sent on chain so that there is a record of what the operator has done. And with that information, in case any operator chooses or with or without intent behaves maliciously, we are able to have cryptographic proof of its behavior, and we are able to enforce slashing as well. So this is the off-chain code. Here you have a few functions, which is the register operator. The first part is you spun up the AVS code, and if you're running an operator, but you cannot just randomly start responding to tasks. EigenLayer enforces some amount of restrictions. So one of this is you need to register, and there is keys and other things required, which we have helper scripts to help you build an AVS faster. So the first part is you would register as an operator, because what would happen is after you register and when you respond to a task, you will be able to see EigenLayer will be able to see that, yes, this operator is actually active in the system and is actually allowed to respond to a task. And sign and respond task that you see on the right side is actually the off-chain code responding to the quote-unquote task name here, which is hello world. And the bottom screen is a monitoring script, which is a piece of code, which essentially says every time I receive a new event, I need to respond to this task. Because if you choose not to, depending on how the AVS is configured, you might be susceptible to slashing and other things. So the next steps here is as Andrew mentioned, we have two big bounties. One for the most novel use case of EigenLayer, and one is some of the best AI apps that all of you would help build on EigenLayer as well. So love to see your ideas on these. These are the links that we use to show the demo, and you have way more information on this page, which I will go through as well. So if you want, you can scan the codes, and you'll be able to get working and forkable code to help kickstart building AVSs. If you want help or understanding of any specific areas, you can reach out to us. And Build on Eigen is our Twitter account, where we tweet out very interesting projects as well. So this is the documentation that will help benefit everyone quite a lot, which is how this AVS off-chain, on-chain, both the systems interact, what contract an AVS would need to write to work with EigenLayer, and how your AVS would need to work with its own contracts is up to you. So it helps differentiate what things we would need to work, what things an AVS would need to work with EigenLayer, and apart from that, whatever you would need for your AVS to work. And also you have deployment scripts, which will help kickstart your project for AVS. And you have the off-chain index.ts code, which I went over. in more detail and explaining on how this works. And you have a task generator as well, which helps you to, simulate traffic and show how your system is actually working. And we have local DevNet deployment steps as well. And if there are any more questions, happy to take. But yeah, that's pretty much it. Thank you.